Okay, and so this brings us to our last limits algebraically technique. All right, so I said to you guys, if you plug in and get 0 over 0, there's 5 different techniques that we've learned thus far. There's also another one called L'Hopital, which we'll learn later in the course. But for right now, this is all we have as far as techniques with the indeterminate form 0 over 0. So what you want to do is when you see absolute value and you get 0 over 0 as your indeterminate form, I told you to consider the left-handed limit and the right-handed limit. And so now you might be wondering, well, how do we do that? Okay, and so that brings us to the discussion of piecewise functions. Okay, so here, looking at this one, I see that I have the limit as x approaches 0 of absolute value of x over x. And so we notice that when I plug in 0 into this, I get the absolute value of 0, which is 0, and then over 0. So I get that indeterminate form, 0 over 0. So now, what I want to do is I want to consider the limit from the left of my function and the limit from the right of my function. Okay. And I want to consider the limit of the right of my function. Okay. Alright, so how am I going to do this? And so I had in your pre-calculus important concepts sheet, I showed you guys that graphically I graphed the absolute value of x function, but then I told you guys it's defined as this piecewise function, where I say the absolute value of x is equal to x if x is greater than or equal to 0, and then it's equal to negative x if x is less than 0. And so where am I getting these things, right? Well, here, if we consider the absolute value of something bigger than 0, let's say the absolute value of 1. Sorry, or the absolute value of 2, actually. Let's just do that. Okay, so I have the absolute value of 2. Well, you guys would tell me, well, that's equal to 2. How about, though, the absolute value of negative 2? Well, you guys would tell me that that would be 2, right? Because the absolute value is, for negative numbers, you get the positive of that. It's the distance from 0 on the number line. Okay, so my point is that when I plug in negative 2 into my absolute value, I actually get negative 2, which is 2. I actually get negative 2, which is 2. Alright, so you guys would tell me it's just 2. But that's where this condition comes from here. Alright, so I'm saying to you, if I have a negative number and I plug it into the absolute value, I'm going to define it as negative of that negative number, which is then positive. Okay, so that's where that piece is coming from. And then the other piece, I'm just saying to you, well, if I plug in a positive number, or even 0, I just get back out whatever I plugged in. So in this case, you saw it, right? When I plug in 2, I just get back 2. Okay, when you plug in 0, you just get back 0. So that's where this condition was coming from. So when x is greater than or equal to 0, in other words, it's positive or equal to 0, I get back what I plugged in. So that's why it's matching here. Alright, whereas if I plug in a negative number, that's not what happens, right? When I plug in negative 2, I get back 2. So I get back negative of whatever the number that I plugged in was. Okay. So that's how that whole thing was defined. And so now, when we go over and try to do these limits here, I need to figure out which condition I should use. So this brings us back to what we were doing beforehand. Okay, so for x values to the left of 0, which function do I want to use? Do I want to use x or do I want to use negative x? And so you look at this condition and I'm saying to you, well, when x is less than 0, you want to use the negative x, right? And so in terms of a number line, if I'm saying x is less than 0, that's all the values to the left of 0. And so I want to be using negative x for the limit as x approaches 0 from the left of negative x over x. Okay, so instead of having the absolute value there, since I'm considering the limit from the left of 0, I want to be using that negative x. Okay. Now if I'm considering the limit from the right of 0, okay, so I'm just going to highlight to you in yellow again. That's why I got the limit as x approaches 0 from the left. Instead of this absolute value here, I plugged in negative x because it's defined for x values to the left of 0. Okay, what about from the right? Well, from the right, I want to use my value x here. So instead of having absolute value, I'm going to say that this is the limit as x approaches 0 from the right of x over x. So that's where I got that from. And so now, simplifying this, I have that this is the limit as x approaches 0 from the left of negative 1. And I have that this is equal to the limit as x approaches 0 from the right of 1. And so these were the properties of limits. Remember, if I have the limit as x approaches some value of a constant, it's just equal to that constant. So in other words, if I have the limit as x approaches whatever value it is of a number, I have that it's equal to just that number. So this is going to be negative 1, and this one's going to be 1. Okay, and so what would we say overall about the limit? Well, the left-hand limit doesn't equal the right-hand limit, and so overall the limit does not exist. Okay, and so here I'm going to note that to you. Note the limit as x approaches 0 from the left does not equal the limit as x approaches 0 from the right. And so the limit as x approaches 0, absolute value of x over x does not exist.